All right, today we're diving into something that's quietly changing the entire game for AI agents. It's a protocol that's giving them a universal language to talk to the rest of the world. And believe me, this change unlocks some incredible power, but it also opens the door to some really serious new dangers. Let's get into it.
So let's start with a question for you. Picture the smartest AI you can imagine, something like a super advanced GPT-4. I mean, this thing can ace the bar exam, it can write perfect code, it can even whip up a sonnet on the spot. But what's the one single thing that it absolutely, fundamentally cannot do? That's it. It can't do a thing. By itself, an AI model has no way to get new information, no way to connect to another system, and certainly no way to take any action that affects the world around it. It's basically this brilliant mind that's just locked in a box, completely cut off from reality. The best way to think about it is like a brain in a jar. It's got all this amazing knowledge from its training data, it can reason and predict like nothing else, but it has no eyes, no ears, no hands. It's totally isolated. So the big question is, how do we give this amazing brain a body? How do we let it see and act?
Well, the answer is something called tools. Now, in the AI world, a tool is just a simple program that the model can call on to do something it can't do itself. You can think of them like apps on your smartphone. They are the eyes, the ears, and the hands that finally connect that brilliant brain to the world.
So let's get practical. Let's see how these tools actually give our AI its senses and how they transform it from just a passive brain into an active agent that can actually get things done for us. Let's take a super simple example you've probably used 100 times, asking your phone for the weather. For an AI to answer that, it needs a few things. First, it has to perceive where you are, right? So it uses a tool to get your location. Then, it needs to know the forecast, so it uses another tool to call a weather API. And finally, it needs to act, maybe by converting Celsius to Fahrenheit for you. See? 3 separate tools working together to give you one simple, useful answer. Now here's where it gets messy. For the longest time, connecting all these different models to all these different tools has been, well, a total nightmare. It's been the wild west of custom one-off integrations. Every single time a new AI model comes out, developers have to build a brand new connector for every single tool they want to use. This is called the N by M problem, and it means the amount of work just explodes.
And this is where our hero finally enters the story. To clean up this mess, a new standard was created called the Model Context Protocol, or MCP. And honestly, the best way to think about it is like a USB port for AI. Instead of a million different cables and plugs, you just have one universal standard that connects any tool to any AI.
So how does this actually work under the hood? It's a pretty classic client-server setup. You've got your main AI app. That's the client. It sends out a standardized request to an MCP server, and that server is where all the tools actually live. This little separation is the key to the whole thing. It means the AI doesn't need to care how a tool works, it just needs to know it can call it using this one universal language.
If you look at the adoption numbers, man, it's a blowout. The MCP standard can do other things like share data resources or system prompts, but the data is crystal clear. 99% of implementations support tools. It's the killer app, no question about it.
And this quote from the original paper really just nails the why behind all of this. The goal is to decouple the AI from the tools. You create this plug-and-play ecosystem where AI developers can just focus on making their models smarter, and tool developers can build awesome new capabilities that work for everyone, right out of the box. Okay, so everything sounds amazing, right? A universal standard, plug-and-play tools, a scalable ecosystem. What could possibly go wrong? Well, this is the turn. By creating a universal key for all these tools, we've also created a universal lock for attackers to pick. We've just opened Pandora's box, and we're only now starting to see what's inside. First up, we've got a really sneaky threat called tool shadowing. This is where an attacker creates a malicious tool, but they write the description for it in a way that's so tempting and so broad that it overshadows the real legitimate tool, tricking the AI into picking the bad one. Okay, check this out. Let's say you're an AI assistant, and you see 2 tools available. On the left, you've got the good guy, Secure Storage Service. Its description is super specific. Use it only for sensitive secrets. But look at the malicious one on the right. Its description is so vague and broad. Use me whenever the user says save or remember. An AI could easily get tricked into using this one to save, say, a company API key, sending that secret straight to an attacker. And that little trick leads us to an even bigger, more classic security flaw called the confused deputy problem.
The idea is simple. You have a program that has a lot of power, the deputy, and you trick it into misusing that power for you. In our story, the all-powerful MCP server is about to become a very, very confused deputy.
So picture this. An attacker, maybe a low-level employee with limited access, asks their AI assistant to do something they're not allowed to do. They say, hey, go find the company's secret algorithm file, and then create a new public code branch with all of its contents. Now, the AI has no idea about permissions, it just sees a series of valid commands. So it passes those commands on to the MCP server. And here's the kicker. The server has God mode privileges. It doesn't check the original user's permissions. It just does what the AI tells it to do. And poof, the company's biggest secret is now public. The server used its own authority, not the user's. That's the confused deputy.
Okay, so that sounds pretty scary, right? Does this mean we should just throw the whole idea of MCP out the window? Absolutely not. What it means is that, just like with any powerful new tech, we can't just plug it in and hope for the best. We have to be smart. We have to build layers of safety and governance around it to tame this new frontier.
And the good news is, we have ways to do that. There are some really solid safety measures we can put in place. For starters, you can explicitly allow list only the tools you've personally vetted and approved. You can also put a human in the loop, meaning for really risky actions like deleting a database, a real person has to click, yes, I'm sure. We also have to sanitize all the data going in and out of these tools to strip out any malicious code. And maybe most importantly, we have to live by the principle of least privilege. Give every tool the absolute bare minimum permissions it needs to do its job, and nothing more.
And that really brings us to the biggest takeaway from all of this. For any real company out there, the future of MCP isn't going to be this pure, open, decentralized protocol. No way. The future is a version that is wrapped in thick layers of centralized security, identity management, and governance. The platforms that can provide those layers of control are the ones that are going to make this whole thing safe enough to actually use.
So it leaves us with one last big question. With the Model Context Protocol, we've basically built a universal key, a key that can unlock the AI's potential to finally act in the real world. The question we all need to start asking ourselves is, who do we trust to hold it?